Hey everybody, Mr. Klein here. I'm going to show you how to use Google Sheets in order to run a hypothesis test. So the first thing you need are your hypotheses. And we are hypothesizing for this. This is problem number 7, that people who have a family history of heart disease, they on average have a higher blood pressure. Specifically, we're talking about systolic blood pressure. So let's test this. Now, in order to do so, we need some information. This is the formula for our test statistic. So we need mu, and mu is going to be the population mean. And we know from reading the problem that the population of all people has an average of a systolic blood pressure of 112 and a population standard deviation of 13. That's sigma. Now, the other things that we're going to need are the sample size and the sample mean. So let's start with the sample size. We can come over here and count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's probably the easiest thing to do when you have a small sample size like this. But imagine we have hundreds of them. You need a better way. And the better way that we use is we use the count function, which you guys learned first semester. There's 10. Next thing is we need our value of x bar. And that is the sample mean. You use the average formula. And we find that it is, in fact, higher. Is it a lot higher? I don't know, but higher than the population mean. Okay, so we now need to plug stuff into this formula. Look at the denominator. That's sigma divided by square root of n. I've found that it's easiest if you go and calculate that. And you do that by taking the value of sigma, which is in D4, and dividing it by, you type in SQRT, that's the square root function, of sample size, which is in D5, hit enter. So there's our denominator for this expression. Now it's time to find our test statistic. If you look at part C on this question, part C is actually what we just did. You can fill that information in. We've got that. Part D says, what is the test statistic value for this sample? And test statistic is just a fancy way of saying find your z-score. Well, we can do this in Google Sheets too. You say equal sign. Now, when you put the numerator in, the x bar minus the mu, you need to make sure that you put it in parentheses. So x bar minus mu, n parentheses, divided by the denominator, which we calculated right here, gives us our answer. Our test statistic is 1.77. Now, this is a right-sided test, like this one right here. We know that it's a right-sided or a right-tailed test because we're theorizing that the blood pressure is higher. So we need to use the 1 minus norm.s.dis formula. So I'm going to come right here and write equal sign 1 minus norm.s.dist of the z-score that is in the cell right above. And there's our p-value. Now, I already changed it to a percent here. I guess we could get rid of the percent if we, maybe we can. So our p-value is 3.79. What kind of conclusions can we come to? Well, look back here. F says to state your conclusions at the 5% level. And our p-value is even smaller than 5%. So we would reject the null hypothesis. However, let's suppose we were running the same test at the 1% level. I didn't want to do that. At the 1% level, we would fail to reject because our p-value is larger than 1%. So translation, this right here is strong enough evidence to reject at the 5% level, but not strong enough evidence to reject at the 1% level.